Okay, in this video we're going to talk about review exercise 15, which is dealing with an F distribution. So random variable x has an F distribution with 9 degrees of freedom for the numerator and 20 degrees of freedom for the denominator. Find out the answers here rounded to 5 decimal places. So we're going to do some probabilities and inverse probabilities here. The bottom question first, what F distributions are most similar to what other standard type of distribution that we've talked about? And then some probability problems. A, the probability that x is less than 5. B, the probability that x is greater than 10. And C, the probability that x is between 4 and 7. So we got a left tail, right tail, and between area there. And then a couple of inverse probabilities, an inverse probability to the left and right. The probability that x is less than A is 0.01, find A. And probability that x is greater than B is 0.05, find B. So see if you can work all these out. All the answers are going to be on the next slide, so be sure that you work all of these problems out before coming back to the video to check your answers. Work them out on your own. Press pause now. All right, well, here are the answers, and I'll show you working these out on a TI-84. If you work these out on like an Inspire calculator, it works in a very similar manner. Kind of clear out some stuff here. Okay, so if we want to do, first of all, F distributions are most similar to chi-square distributions. Both of those distributions start at the origin, and at least for the PDF, well, at least if the degrees of freedom are high enough, it starts at the origin, comes up to a maximum, and then comes back down to the x-axis asymptotically on the right. And they're skewed to the right. Okay, so the probability that x is less than 5, probabilities can be found with the CDF. So we're going to use the chi-square. Now we're going to use an F. It's an F distribution. F CDF, that's number 0 here. And so less than 5 is really going to start at 0. So 0 here up to 5. And it has two parameters that describe which F we're talking about. They're called their degrees of freedom. They're really called degrees of freedom 1 and 2, or numerator and denominator. So the first one here for the numerator is 9, and the second one for the denominator is 20. Now next unit we'll talk a little bit about how you can figure those out in the context of the problem, what they might be. But for now they're just numbers that I give you to identify which F distribution. And so there it is. There's the probability. Greater than 10, two ways to do this. We can go here and do chi-square CDF. We can go from 10 up to infinity. The problem is we don't know what we might use for an upper in place of infinity. I'm going to use 1,000. I think this will probably work pretty well. Okay, but since we have a hard end of 0 on the left, we could do 1 minus a chi-square CDF from 0 up to, where are we, 10, with that degrees of freedom, and that turns out to be, well, the same thing. So anytime it starts, remember probabilities are always less than 1, so anytime you see something that starts with something other than 0 point, that means that you better look at the end of here. This e negative 5 means times 10 to the negative 5. That means we got to be moving that decimal around a little bit. In this case, to the left 5 places, crosses over the 1, and then 4 more zeros. So that's 0.4 zeros, and then a 1 and some other stuff. So that rounds off to 0.00001 to 5 decimal places. We want to find the probability between the two values. We just put in the two values for the 4 and the 7. 2 degrees of freedom there, 9 and 20, and then we get the probability there. Now, we want to do an inverse F. Unfortunately, for most of you, you will not have an inverse F distribution, or at least those who are using a TI-84 or TI-83 calculator will not have an inverse F. If you've got an Inspire calculator or TI-89, they do have an inverse F built in, and so you can use that instead. The way that would work, if you have it, is you just do inverse, you put the probability to the left, so it would just be inverse F of 0.01, comma, then you give the degrees of freedom, 9, 20. Okay, and so that works out pretty easily with that. But on here, here's how we're going to have to do it. Okay, actually here I just pulled up a Inspire to show you there. Let's make this a little bit bigger. Okay, so in the Inspire it's pretty easy. It's menu, you go to probability and distributions to get these things, normal, PDF, inverse norm, and so forth. And notice you do have an inverse, you know, for the normal, T, chi-square, and F, you have a CDF, PDF, and inverse. So this is an inverse F, same way for the F. So F here, you put in the area to the left, which was, in this case, was 0.01. And you have to put in degrees of freedom for the numerator of 9 and for the denominator of 20. Hit OK. And there's the probability we're looking for. So it's pretty easy for the inverse F. So the inverse F and inverse T and inverse norm and the inverse chi-square, they all basically work the same. The first thing you have to do is put in the probability to left. Next, you have to put the identifying characteristics to know which one you're talking about. In the case of an inverse F, that's the degrees of freedom numerator, degrees of freedom denominator. Now, we don't have that on the Inspire. I mean, you do have it on the Inspire. You don't have it on the TI-84. So what we're going to have to do on the TI-84 is we're going to have to graph the F CDF. Now, I mean, really, this is what you're doing all the time. The others are just kind of really a shortcut. Okay, and so F start at 0, so we're going to go from 0 to X, and 9 and 20 are the degrees of freedom. That's right. So hit paste and put that in your Y1. For Y2 we put in the probability to the left as a constant, which will be a horizontal line. So we want to start at 0 and go out to the right. I don't know how far. And then it's a CDF, so it should be going essentially from 0 to 1. I went a little beyond that. So let's see how this one looks. As long as we can see that point of intersection, we're good. Actually, it looks like I'm probably going quite a bit too far out to the right here. Let me stop it and redraw it. Probably, you know, half that's going to be plenty good enough. Let's go out 12, let's say. We just need to see it kind of leveling out at the top, going up from 0 to 1. Okay, it's going to take just a minute for this thing to graph out for us. Okay. Now, let's see what happens with this. When this graphs out, then we want to just calculate the intersection. Now, the 0.01 is a horizontal line, but we may not be able to see it. It's so close to the x-axis. So it's okay, we're about done with that, and there's a horizontal line graphed really fast. So now we want to do calc intersection, number 5, and we select the graph, and the second curve is a horizontal line, y equals 0.01. You can't see it, but there it is. Enter, and we're going to slide along there with our left or right arrows till we get close to where they cross. Somewhere in this vicinity right there. Hit enter, and we get a value of y equals 0.01 and x of, if I've got my answer right, it should be about 0.20799. Okay, which is what that is there. By the way, if we quit and just hit X, there it is again. Okay, and for the last one here on E, we do the same thing, except it's a probability to the right, so we do 1 minus 0.05, or in other words 0.95 if you'd rather. And this time we want to calculate that intersection, and that may take a little bit for this to graph, but in fact I'm going to skip ahead. And there's what the screen looks like when you're done with calculate intersect. And so that's how you can get a probabilities and inverse probabilities about a chi-square very accurately, very quickly. No tables allowed or required, and very, very accurate and very easily found probabilities. A little harder than the normal and the t because it doesn't have an inverse f built in, but not too hard for us. We just got to graph the FCDF and horizontal line and calculate the intersection for the inverse probabilities. Probabilities, more straightforward, straight out FCDF problems. Works just like normal, t, and the chi-square.